Welcome to the TS Learning software. My students and I are thrilled to have you join us in this educational journey. Hello, I am Amir. This section is about the limit of a function. Concept. A graph can represent the relationships between two or more quantities. For example, the equation, y equals 2x plus 3. Represents a relationships between the variable x and y. We can plot all graphs by substituting values for x and determining the corresponding y values. This is the graph of y equals 2x plus 3. For this purpose, it is sufficient to successively assign value to x in the given formula and obtain y. And then we connect the obtained points. Now I want to find the value of y, from the graph when the value of x is half. For this purpose, move horizontally along the x-axis until we reach the tick mark that indicates the x value half. We can move from two directions, left or right. From here, move straight up or down until we reach the graph. From here, move left or right until we reach the y-axis. The point on y-axis is the y value. So we can write f of half is equal to 4 or y equals 4. Pay attention to the movement of the variable on the x-axis as it approaches the number 0.5 from left and right. Sometimes we can only move from one direction to the specific number on the x-axis. For example, in this graph, when we want to move horizontally along the x-axis until we reach the x value 4. We only have one direction from the left, because there is no graph on the right side. It is clear when we want to move horizontally along the x-axis until we reach the x value 4 from the left. The point where our line intersects the y-axis is 2, then we write f of 4 is equal to. Look at this graph. A sketch of graph f of x is shown. We only have one direction from the left to reach the value x equals -1 on x-axis. And only have one direction from the right to reach the value x equals 2 on x-axis. Now we can easily find y value of both. Some points in the graph are undefined, but it is still possible to get very close to them. Look at this graph. This graph is defined for all values of x except for 5. So we can only approach 5 because 5 is not defined. We can approach from two directions, left or right. We see that as x gets closer and closer to 5 from the left, y is closer and closer to 3 from the below. It is clear that its value is slightly less than 3. We see that as x gets closer and closer to 5 from the right, y is closer and closer to 3 from the top. It is clear that its value is slightly greater than 3. As x approaches 5 from the left, but not equal to 5. Expressed in symbols. Negative sign above the number means, x gets closer and closer to 5 from left and its value is slightly less than 5. As x approaches 5 from the right, but not equal to 5. Expressed in symbols. Positive sign above the number means, x gets closer and closer to 5 from right and its value is slightly greater than 5. When we write, this is read as, x tends to a minus. It is clear that the value of x is slightly less than a value. When we write, this is read as, x tends to a plus. It is clear that the value of x is slightly greater than a value. In this graph we saw that as x gets closer and closer to 5 from the left, y gets closer and closer to 3 or, expressed in symbols. Limit f of x as x tends to 5 minus is equal to 3. It's called one-sided limit from the left or the left-hand limit of f of x when x tends to 5 minus. In this graph, we saw that as x gets closer and closer to 5 from the right, y gets closer and closer to 3 or, expressed in symbols. Limit f of x as x tends to 5 plus is equal to 3. It's called one-sided limit from the right or the right-hand limit of f of x when x tends to 5 plus. The following graph of f of x is drawn. Determine the left-hand limit of f of x as x approaches 3 or, x tends to 3 minus. The answer is 1. Now, determine whether the resulting exact value is greater or less than 1. Just look at the number 1 more carefully. It is clear that its value is slightly less than 1. So we can put minus sign on the top of 1. Now determine the right-hand limit of f of x as x approaches 3 or, x tends to 3 plus. The answer is 4. It is clear that its value is slightly less than 4. So we can put minus sign on the top of 4. The following graph of f of x is drawn. Find the value of limits. The accuracy of the answer is not important. X tends to 3 minus. And the answer is 2. X tends to 5 plus. And the answer is 1. X tends to 8 plus. And the answer is 0. X tends to 8 minus. And the answer is 1. X tends to minus 1 minus. It's not defined. Theorem. Limit of f of x as x tends to a. Exist and is equal to L if and only if. Limit of f of x as x tends to a minus. And. Limit of f of x as x tends to a plus. Both exist and both are equal to L. L is the specific number. If the left-hand limit and the right-hand limit are not equal, we say that the two-sided limit does not exist. For example, if limit of f of x as x tends to 4 minus is 7, and limit of f of x as x tends to 4 plus is 7. Therefore by theorem, limit of f of x as x tends to 4 exists and is equal to 7. For example, if limit f of x as x tends to 5 minus is equal to 3, and limit f of x as x tends to 5 plus is equal to 6. Therefore by theorem, limit f of x as x tends to 5 does not exist. Find limit of f of x as x tends to 10, and show that limit of f of x as x tends to 10 is not equal to f of 10. As x approaches 10 from the left, the limit of f of x is minus 3. As x approaches 10 from the right, the limit of f of x is minus 3. For finding f of 10, the point on the y-axis is one value. So, limit of f of x as x tends to 10 exist and is equal to minus 3. But not equal to f of 10. Limit at infinity. When x increases without bound. Look at this. We write the symbol positive infinity just tells us that a variable increases without bound. When x decreases without bound, look at this. We write the symbol negative infinity just tells us that a variable decreases without bound. A sketch of a graph of a function is shown. Find limit of f of x as x tends to plus infinity. We see that when x increases through positive value, y gets closer and closer to 3. So, limit of f of x as x tends to plus infinity is equal to 3. Note, in solving limit problems, the movement on the x-axis can be performed mentally on the graph itself. Find the limit of f of x as x tends to 3 minus. The answer is 1. Find the limit of f of x as x tends to 3 plus. And the answer is 4. Example. Find limit of f of x as x tends to plus infinity. The answer is 1 minus. It is clear that its value is slightly less than 1. Example. Find limit of f of x as x tends to minus infinity. The answer is minus 1 plus. It is clear that its value is slightly greater than minus 1. Infinite limits. As x approaches a, f of x increases without bound. Which is written. And as x approaches a, f of x decreases without bound. Which is written. A sketch of a graph of a function is shown. Find limit of f of x as x approaches 2 minus. F of x decreases without bound. And the answer is minus infinity. A sketch of a graph of a function is shown. Find limit of f of x as x tends to plus infinity. f of x increases without bound. And the answer is positive infinity. Your effort is appreciated.
Thanks for watching.